All right, so a buddy of mine picked up a Tripp Lite PR-25 power supply. This is a big-ass linear power supply. And he got it off of Craigslist really cheap, and he was going to give it to me for my bench and doing other stuff. I have a PR-60 in the other room, and I'm going to move into here and put this into my other room for my radio equipment because I don't need 60 amps. So yeah, he gave me the supply, and he was on the assumption that it worked, but it doesn't. So let's figure out what's going on with this. I think that we're probably going to find something stupid. I don't know. It looks in brand new shape. It doesn't look like it's seen a lot of use at all, if any. So it's kind of weird. So let's go to the other camera here and see if we can see anything obvious. I mean, like I said, everything looks brand new on this. There's not a scratch on it. Everything looks fine. It doesn't look like any wires have ever been hooked up to this, but that doesn't mean anything. Yeah, all right. I don't know. I'm gonna try and plug it in, turn it on. The light lights up, so that's a good sign that we have power at least getting to the unit. But let's get our DC output here. All right, let's show. .8 volts. Dead as a doornail. All right, so apparently there's an issue in this. I don't know if it's in the whether it's the transformer or not. If it's the transformer, this thing's a piece of 30-pound garbage. So I'm kind of hoping it's not the transformer. I'm hoping it's something in the regulator circuit or maybe in the bridge rectifier. So I'm just going to take the cover off and see what we got here. I'll come back once I have the cover off. Okay, so I have the power supply apart right now, and we're going to be checking to see if the transformer is outputting anything. And we got a AC going into this bridge rectifier here, and the output is going to be the DC. But do not get fooled with some power supplies. They are center tapped. This one happens to be center tapped, and that the two output wires are not going to be plus and minus DC. They're going to be plus DC. So yeah, don't get fooled by that. If you put your meter across the DC output, you're probably going to get nothing, and you're going to think the bridge rectifier is no good. What you want to do is find that center tap, and that wire happens to be right here coming out of the transformer. You're going to want to put your negative lead on that and your positive lead on both. These actually go to the same place, the two red wires. And so if I come around the side here, I can see that those two are indeed connected on this rail here, and that center tap comes in and goes to right here. So if I turn this on and I see DC voltage, it's going to be good. And let's see what we got. Power on. DC volts. Yep. All right, we got 21 volts there. So the transformer is good. We verified that. We verified the bridge is good. And what we verified now is that something in the regulator circuit is not working correctly here. We have some transistors we can check. I don't know. We'll have to pull that board out. It looks like you got to pull these lugs apart to get that board out and see if there's anything that's cooked or a bad solder joint on the back there. Most likely it's going to probably be a regulator IC or a transistor, so something to that nature. I don't see anything that's exploded, so most likely it's going to be something like that. So I'm going to pull that board out and see if we can get a better idea. Okay, so I've been all over this power supply, and I don't see anything wrong on the filter board or the pass transistors or the rectifier. I don't see any issue at all. So what I'm thinking is that something is wrong on this regulator board. And what they use here is two ICs. There's a quad op amp down here. It's a flat SMD, and they use a through hole component here, and I think that's also a dual op amp, and this is a quad op amp. So I think the best thing to do here is try and change those out, because I've tested every component on this. I've tested the SCR and the NPN transistor, all the diodes. Everything looks good. I don't understand why it's not working, other than I can't tell what's going on with the chips because Tripp Lite won't send me a schematic. I've asked them. They told me to go screw. Well, they didn't tell me to screw, but they just politely said no. So only thing we can do is try and change these two ICs out, and hopefully it works. So that's what I'm going to be doing now. We'll put a little flux on here first. This should come off pretty easy. There's no other through surface mount devices on this, so I'm not worried about blowing any components off. I'm going to gently heat this up and then move in closer and see if we can get this to come off. Let's get the board a little preheated before you go in there for the kill. You don't need a ton of air. I like to run low air, higher heat. It tends to give a little better result and not blow the components off. If there's other SMD components close by, they'll tend to just sit in the same spot. If you got the air pressure up too high, you're gonna risk blowing other components off the board. But we don't really have to worry about that too much here. So now I'm just going to go in and see if I can get these pins to start to flow. Might need a little bit more heat. Yeah, we're going to have to crank the heat up a bit. You gotta keep it moving, because these things will cool fast. It's just starting to melt. I'm trying not to heat it up too fast. All right, we can give this a little bit more heat now. There we go. We'll let that cool for a second, and then we'll wipe the pads down. If you go after that right now, you're going to risk, you could risk moving these pads or destroying them because of the hot air. As sometimes will release the bond between the pad and the board. So we're just going to let that sit for a second and let that try to cool down. You don't have to wait till it gets to room temperature, but just don't go after it right away. Okay, so now I'm going to put a little flux on there and just try and wipe those pads up with the soldering iron. And the solder wick. Now, like I said, just be very careful. If the solder wick sticks to the pads, don't yank on it. You'll have to try to heat it off because you can tear those pads right up. And try to just be very gentle with it. These seem to be very sturdy pads. It's a very decent quality board, so I've seen some where you really can't help but lift some of these dead pads that don't have anything hooked up to it. I'd say that's probably good enough. So now I'm just going to take a Q-tip and some alcohol and just clean the area up before we lay down the new component. Still sticky. That's the only thing I don't like about these type of Q-tips is when it starts to get sticky, it'll start pulling the fur off of the Q-tip and throwing it on your board. So I have some foam ones, but I can't find them at the moment, so just keeping this wet. We'll dry it with, we'll just let it air dry and we'll lay the new chip down. Okay, good. That's good enough. So now I'm just going to take a new chip. I got two just in case. And we're just going to put that aside for a second. I like to put the flux down before the chip so we get it under the pins. And it kind of gives it a little bit of tension to hold the IC in place when you're tacking it. I gotta change my tips now. Let that warm up for a second. And now we can put the new component down. Looks good for my house. All right, so I'm just going to tack one corner first. Going to place a little pressure on the top of the chip and just put some solder on the end of my iron and just tap that leg. Now you can do some kind of correction here if the pins look a little off. They don't look too bad, they look fine. So I'm going to put more solder on my iron here. Hold that down. Give this leg a tap. Alright, so now we can go ahead and solder the rest of the legs here. This little angled tip works very well for this. You can of course use a couple different methods here. You can use a drag method, but this pin pitch is not extreme, so just going to solder it. See if we can get in there a little tighter. A little tight working around this resistor in the cap, but not too bad. This thing really likes to pull the solder. Yeah, a couple of pins got a little extra solder than I would have liked, but oh well. It's still a good connection. So now I'm just going to take a Q-tip again and just wipe down the area. Get that flux up. We'll have to clean that up a little bit, but I think it's good enough to test it out. Alright, so it's pretty much cleaned up, so there's the final product there. Not too bad. Now, I think what I'm going to do on this one is I'm going to pull it up and socket it. And so if I ever have to do this again, I can just pull the thing out and pop it in without a problem. Alright, so I'm just tightening up these connectors here, all these studs on this board here. Should be good to test this. I'm just going to put the connectors back on from the filter board and the transformer, and we should be ready to test this. So let's go to the test equipment cam and we'll see what we got here. We got these two studs here. These go through the case, and these are what give you your 13.8 volts output DC. So we're going to just hang it out on the side here and try not short it up against the case, because I don't want to put this all back together if there's still other issues. So I think I've already got my meter on DC. Yep. All right, I hope that was it. I'm pretty sure that was it, because there is really nothing on this board that is, you know, could be the problem here. Other than that, I mean, I've checked the, like I said, I've checked the SCR, I've checked the NPN transistor, I've checked the diodes that are on here. All the resistors look okay. I didn't measure them, but logically, these two chips here are responsible for the regulation. So I am pretty sure that that was the issue. So let's see how good my prediction was. Let's turn it on. Was that in the shot? Okay, yep, the multimeter is in the shot. Now I'm going to just stick my probes on those two studs and see what we get. Let's turn the supply on first. All right, she lit up like she should. And, nice. All right, 13.785 volts, close enough to 13.8. I think we got this thing going again. So, yeah, that was good. Now, let me just go back to the camera here. So, what I didn't show you was I actually unsoldered the pass transistors off the back, well, actually on the board, on the filter board, and I test those to make sure that none of those weren't shorted or open. I made sure those were okay, the resistors for those, and those were all okay. I tested every component I possibly could before I ended up ordering those ICs, because I don't like ordering parts unless I'm absolutely sure what's going on. And I wasn't sure because the company would not give me schematics, and you know, I asked for them and they didn't want to give them up. So they give you no choice sometimes to just kind of just swap parts out. And it was cheap enough. I think the ICs I put in here were under $3 or $4 shipped. So it was worth it. You know, I got a nice supply now. and this will run some equipment that I have, and I plan on bringing another supplier in here that has some more current capabilities, so I can really do some more testing on some amplifier stuff. So yeah, I hope you guys enjoyed this video. If you have a Tripp Lite PR-25 and your pass transistors are good and all your other parts look good and everything else is good, it's probably those two ICs. Swap those out and see what happens, and you might get lucky here like I did, and you'll have your supply again. All right, guys, if you liked the video, thumbs up, and subscribe if you're not a subscriber, and come back and we'll do some more videos. Have a good night.